Relationship between the coefficient and the roots of a quadratic equation. Sum and product of the roots of the quadratic equation. There are other relationships that can be observed between the coefficients and roots of quadratic equation. If x sub 1 and x sub 2 are the roots of quadratic equation ax squared plus bx plus c equals to 0, using the quadratic formula, the roots are x sub 1 equals negative b plus the square root of b squared minus 4ac over 2a, and x sub 2 equals negative b minus square root of b squared minus 4ac all over 2a. Sum of the roots of the quadratic equation. To derive the formula, we have x sub 1 plus x sub 2 equals negative b plus the square root of b squared minus 4ac over 2a plus negative b minus square root of b squared minus 4ac all over 2a. Since the given fraction is a similar fraction, therefore, we will just simply add the numerator and copy the denominator. Since in this case, we have plus and minus, therefore, the two given term will be subtracted. Therefore, this term will be cancelled out. What left is negative b and negative b. That's why, adding the two given term, we have negative 2b all over 2a. Simplifying these two, cancel 2 to the numerator and denominator. Therefore, the sum of the roots of a quadratic equation will be negative b over a. Products of the roots of the quadratic equation. To derive the formula, x sub 1 times x sub 2 equals the quantity negative b plus the square root of b squared minus 4ac all over 2a times the quantity negative b minus b squared minus 4ac all over 2a. X sub 1 times x sub 2 is equal to negative b squared minus the quantity square root of b squared minus 4ac squared all over 4a squared. Simplifying it, we have b squared minus b squared plus 4ac all over 4a squared. Let's subtract b squared minus b squared. Therefore, x sub 1 times x sub 2 is equal to 4ac all over 4a squared. Cancel out 4 and a. Remember, if you will be expanding this is a multiplied by a. Therefore, the product of the roots of a quadratic equation is c over a. Let's have example number 1. What is the sum and product of the roots of the quadratic equation 2x squared plus 4x minus 1 equals to 0? Take note that to get the sum and product of the roots of the quadratic equation, your quadratic equation should be in the standard form. After transforming your given quadratic equation in standard form, identify your a, b, and c. In this case, this example is already in the standard form. Therefore, I will just simply identify what are a, b, and c. So my a is equal to 2, b is equal to positive 4, and c is equal to negative 1. Now, I can now proceed to get the sum and product of the roots of the quadratic equation. So I'll be solving first for the sum of the roots of the quadratic equation. So given the formula, x sub 1 plus x sub 2 is equal to negative b over a. Substitute the given value. Negative, the value of b will be 4 over 2. Simplifying it, negative 4 divided by 2 is negative 2. For the product of the roots of the quadratic equation, we have x sub 1 times x sub 2 is equal to c over a. Substituting it, we have negative 1 all over 2. Since negative 1 over 2 cannot be simplified, therefore, the product of the roots of the quadratic equation will be negative 1/2. Let's check. Example number 2. What is the sum and product of the roots of the quadratic equation 5 equals 3x minus x squared? Since the given quadratic equation is not in the standard form, let's transform first the quadratic equation in standard form. Let's move 3x minus x squared to the other side of the equation and equate it by 0. Remember, in moving the terms or numbers within the equal sign, the sign of that numbers will be changed. Therefore, negative x squared will become positive x squared. Positive 3x will become negative 3x. Copy positive 5 and equate it by 0. Since the given is already in the standard form, let's identify one by one the values of a, b, and c. In this case, since x squared do not have any numerical coefficient, therefore, it is automatically 1. Therefore, a is equal to 1, b is equal to negative 3, and c equals positive 5. We can now substitute for the sum and product of the roots of the quadratic equation. Let's solve first for the sum of the roots of the quadratic equation. So our formula again is x sub 1 plus x sub 2 is equal to negative b all over a. Substitute the given value. So we have negative times negative 3 all over 1. Multiplying a negative by a negative will give us a product of a positive number. Therefore, this will become positive 3 all over 1. Simplifying 3 over 1 will give us a quotient of 3. For the product, let's just substitute by the given value. The product is x sub 1 times x sub 2 is equal to c over a. The value of c in the given equation is 5, and the value of a is 1. Simplifying 5 over 1 will give us a quotient of 5. Therefore, the sum of the roots of the quadratic equation is 3, and the product of the roots of the quadratic equation is 5. Let's check. Example number 3. Find a quadratic equation whose roots are x sub 1 equals 2 and x sub 2 is equal to 7. Solution. Let's have solving for the sum of the roots. X sub 1 plus x sub 2 is equal to 2 plus 7 equals 9. Just simply substitute the given values. Solving for the product of the roots, x sub 1 times x sub 2 is equal to 2 times 7 equals 14. Therefore, the quadratic equation is x squared minus 9x plus 14. Remember, since the given is a whole number, therefore, the denominator is 1, and that is the value of our a. The value of our b is the sum of the roots. Now, since the sum of the roots is positive, therefore, it will become a negative value of b. Then, for the constant term, the value of the product is 14. Therefore, c is equal to positive 14. Example number 4. Find a quadratic equation whose roots are 3, positive and negative square root of 2. In this case, remember that since we have a positive and negative, we have two values of x. Let's have the solution. Solving for the sum of the roots. 3 plus square root of 2 plus 3 minus square root of 2 equals 6. Just simply canceled out positive square root of 2 and negative square root of 2. And just simply add 3 plus 3. That's why we have 6. Solving for the product of the roots. The quantity 3 plus square root of 2 times the quantity 3 minus square root of 2 is equal to 9 minus square root of 4. Simplify square root of 4. That's why we have 9 minus 2 equals to 7. Therefore, our quadratic equation is x squared minus 6x plus 7 equals to 0. Thank you.